All right, on number 1, we are just looking for the value of each variable here. So on the first one, if I am multiplying two terms with the same base, I would add the exponents to combine them. So here I'm just adding -6 plus 10. That would get me 4. So here a would have to be 4. On B, 5 to what power equals 1 over 5? So first of all, if we see that base going to the denominator, right off the bat, I know that my exponent is going to have to be negative. Now, this becomes just 5 to the first power. Even though we don't see the exponent, it's really 5 to the first power in the denominator. So that means that my b would have to be -1, right? If this was 5 to the negative first power, I would take that to the denominator and make the exponent positive. On C, if I am multiplying two things with different bases, but the exponents remain the same, then I can multiply the bases together. That means C has to remain 3. If the bases are different, but the exponents remain the same all the way through, I can multiply the bases together. On D, if I am raising a power to a power, I multiply them together. So in this case, we are just trying to determine 3 times what equals 15. Well, 3 times 5 equals 15. On number 2, we are in the top row trying to write every single one of these as 9 to some power. So I'm just going to go ahead and do that right off the bat. My whole top row should be 9 to some power. In the bottom row, then, we are trying to rewrite using roots. So I'll start here. If 9 to what power equals 1 over 3? Well, first of all, I see that my term is going to the denominator. That means that my exponent is going to be negative. Now, I basically have to figure out 9 to what power equals 3. All right, well, the square root of 9 would be the same thing as 3. Right? So I can say the square root of 9 equals 3, but in terms of a power, I know that 9 to the 1/2 is the same thing as the square root, right? Square root is the same thing as a 1/2 power. So if 9 to the 1/2 equals 3, I can say 9 to the -1/2 equals 1 over 3. On the second one here, I am rewriting as a root. So first, I see a negative exponent. I'm going to, right off the bat, take that to the denominator and make my exponent positive. But then I can go a little bit further and rewrite this as a root. Whenever I have a fractional power, the denominator of that fraction is the root. So this would be the third root of 9 to the 4th power. Whatever the numerator is of that exponent stays the exponent here. Now on the third one, 1 over the 5th root of 9. So similar to the first one, I know that my exponent is going to be negative because my term is in the denominator. All right, so now we're thinking backwards on what we just did. If I've got the 5th root of 9, well, the 5th root tells me the denominator of my exponent is going to be 5. The numerator then is the whatever exponent is on here. Well, I don't see an exponent. If I don't see an exponent, that means it is 1. So 9 to the -1/5 power would be the same as 1 over the 5th root of 9. The next one, 9 to what power is 1? Well, anything to the 0 power is 1. So this should be 9 to the 0. On this one, just rewriting 9 to the 2/7 power using a root. Well, again, the 7 is the denominator. That means that will be my root. So this will be the 7th root of 9 to the 2nd power. Now, I mean, we could go one step further and write this as the 7th root of 81 if we wanted to. We could go ahead and do 9 squared, but we don't have to. We can just leave it like this. On the last one, just going backwards, I see I have a fifth root, so that will be the denominator of my exponent, and then the numerator is the current exponent. So I could rewrite this as 9 to the 3/5 power. On number 3, we are just solving each of these equations. Now, all is in bold here because some of these will have multiple solutions. The first one, if I am solving x squared equals 15, well, to undo the square, I'm going to take the square root of both sides. So here, the square and the square root undo each other, and I just get x by itself. Now over here, when I take a square root as part of the solving process, we will get a plus or minus. So I will get 2 answers. Now 15 is not a perfect square, so I can just leave my answer as plus or minus the square root of 15. On the second one, I'm doing the exact opposite. This time I need to undo a square root. So to do that, I will square both sides of my equation. Again, the square and the square root cancel out over here, and then 11 to the second power is 121. And we do not include a plus or minus here. If I am squaring a value, that is only going to be a positive value. On C, we would think we should approach this the same way that we just did B, right? To undo the square root, I can square both sides. However, we've talked about the idea that I can never have a square root by itself equal to a negative number. If we ever see something like that, we know there are no solutions to that problem. On D, I want to undo a cube, so I will take the cube root of both sides. The cube and the cube root undo each other over here, and the cube root of 125 is a perfect cube. The cube root is just 5. Now remember, if I am taking a cube root, there is only one answer, just positive 5 in this case. This is not plus or minus. On E, the exact opposite. To undo a cube root, I will cube both sides. So cube and cube root cancel out, and 3 to the third power is 27. So the only one of these that we actually got 2 solutions for was A. On number 4, we are just asked for the number of solutions to each of these equations, not the actual solutions, just the number of solutions. So what I can think is if I draw a horizontal line at 10, how many times does that line hit my graph? I can see that it hits 2 times. So I'm just going to say here the number of solutions is 2. We're not asking for what the actual solutions are, just how many solutions there are. So on B, right, at 3, if I draw a horizontal line through here at 3, I can see I only hit the graph 1 time, right, just that point right there. So the number of solutions here is 1. If my function equals 7, how many times does my graph have a y value of 7? Well, twice, here and here. So the number of solutions for C is 2. And then finally for D, if I draw a horizontal line at -2, right, how many times do I hit my graph? Well, none, right? My graph does not go down that far. So in this case, there are 0 solutions. Now the rest of the problems on here, we are solving equations. So I can see here, I've got a square root already by itself, right? That's the first goal. Remember, always get the root by itself first, equal to a negative value. We just talked about the idea that we can't have that, right? I can't have a square root equal to a negative. So in this case, there are no solutions. On the next one, my first goal is to get the cube root by itself. It's currently being multiplied by 5, so the first thing I will do is divide both sides by 5. And I'll get the cube root of x equals negative 3. Now, on the last one, we just said we cannot have a square root equal to a negative, but we can have a cube root equal to a negative. So I can continue here. I can just raise both sides to the third power to undo this cube root. So on the left side, I get x by itself, and negative 3 to the third power, negative 3 times negative 3 times negative 3 would be negative 27. Don't forget, you can always double check your answer. So if we plug that back into the original and do 5 times the cube root of negative 27, we will in fact get negative 15. On the next one, I want to get what is being squared by itself first. So I need to add my 20 over to the other side first. So I will end up with x minus 3 squared equals 16. Now that I have this thing that is being squared by itself, I can take the square root of both sides of my equation. So on the left side, the square and the square root cancel out. And on the right side, I get both positive and negative 4. Don't forget that whenever we take a square root in the solving process, we're going to have a plus or minus. So we talked about from here, whenever we have a plus or a minus, immediately set up two different equations. X minus 3 equals positive 4, and x minus 3 equals negative 4. So to solve both of these, I'm going to add the 3 over, and we'll get positive 7 and negative 1. Okay, and again, just to double check ourselves, we could plug each of those back in for x into the original problem and make sure that they work. In this case, they do. On the next one, again, the first thing I want to do is get whatever is being cubed by itself first. So I'm going to start by adding 9 to both sides. So negative 1/4 x cubed equals 16. Now, I still need to get this negative 1/4 out of here. I can think about this in two ways. Since it's currently being multiplied, right, negative 1/4 times x cubed, I could divide both sides by negative 1/4, or I can think about multiplying by the reciprocal. So in this case, the reciprocal would be negative 4 over 1. So if I multiply both sides by negative 4 over 1, that's actually the same thing as dividing by negative 1 over 4. So we get x cubed by itself, and then on the right side, 16 times negative 4 would be negative 64. Now that I have the thing that is being cubed by itself, I can undo that cube by taking the cube root of both sides. That gets us x by itself, and the cubed root of negative 64 is negative 4. 64 is a perfect cube. On number 9, again, I want to get the cube root by itself first, so I will start by adding 4 to both sides. So we'll have 3 times the cubed root of x plus 9 equals 9. Now the cubed root still isn't by itself. I'm still multiplying by this 3. So I need to now divide both sides by 3. And we'll get the cubed root of x plus 9 equals 3. Now that I have the cubed root by itself, now I can undo that by raising both sides to the third power. So on the left side, cube and cube root cancel out. We just get x plus 9. And on the right side, 3 cubed is 27. So all I have to do then is subtract the 9 over, and we get 18. On number 10, I want to get x squared by itself. So I'll start by subtracting my 11 over. So we'll get negative x squared equals negative 36. I still have to get rid of this negative sign to get x squared by itself. So I will then divide both sides by negative 1 and get x squared equals positive 36. So now, to undo the square, I can take the square root of both sides. Square and square root cancel out. We get x by itself. And the square root of 36, don't forget your plus or minus, has two answers, so plus or minus 6. So my two answers are both negative 6 and positive 6. On number 11, again, I want to get whatever is being squared by itself first. So I need to get rid of this 7. So I'll subtract the 7 over. So 4 times x minus 5 squared equals negative 4. Then I will divide both sides by 4 to get x minus 5 squared equals negative 1. And then to undo the square, I can take the square root, but I can't take the square root of a negative number. So right here, I'm done. That means that there are no real solutions to this problem. On number 12, the square root is already by itself, so all I have to do is square both sides. We will get x plus 8 by itself equals 5 squared is 25. Subtract the 8 over, and we get x equals 17.